having different scheduling algorithms. Okay, so first one is a first come first search algorithm. So let us understand how you're going to solve this any scheduling problems which is coming from first come first search, which is the most easiest. Now before that, you have to know what is non-preemptive and preemptive method. This is non-preemptive method. What is preemptive and non-preemptive? Non-preemptive means the process would, if two processes are there in the ready queue, after the completion of the P1 or after one finally finishes completion, only P2 can come. But in preemption, if I'm having P1 and P2, P1 complete only like a little bit, 1/4 of its process, and after that it is forcibly you're removing it, and then P2 come to execution. Then again P1 can come after P2. You can maybe remove after half of its process done, you can remove P2 again, and P1 would come and P1 would finish its execution, then P2 would come. This is preemptive method. But in non-preemption, only after one process finishes completion finishes, only the second process can come into the CPU to finish its processing. Okay, this much we have understood about what is preemption and what is non-preemption. So in preemptive method, we told that maybe it can forcibly be removed without its full process being completed, and then P2 can come and it will go back to the ready queue and it will wait. After P2, it can also, after P2 P1 can come again and complete its process. But it's not the case of non-preemptive. In non-preemptive, only finally the whole process completes, only then the other process can basically come in the case of non-preemptive. So this first come first search algorithm actually strictly follows non-preemptive. And in first come first search algorithm, it says that the CPU would assign the process, CPU is assigned to the process who comes first in the ready queue. That means if I am considering the ready queue here, if this is the order, first P1 comes, then P2 comes, and only after P1 fully completes, only P2 can go to its can be assigned the CPU for its process execution. Okay, so this is the case in first come first search. As the name suggests, the first, which is the first process, the first process which comes first would be executed or will get the CPU first. So now this is the question which we are going to solve and whose Gantt chart we are going to basically draw. And in this question, you have to understand here is that whenever the processor is given, their corresponding arrival time would be given to us and the burst time would be given to us. Now arrival time is the time in which it reaches the ready queue, right? It reaches the ready queue, that is the arrival time. And burst time is how much time the process needs for execution. For example, P1 arrives at time 2 seconds. At the 2 second, P1 would arise and it would require 2 seconds of time. That is when it arrives at 2, it requires 2 seconds. That means at 4 only it will exit, because it requires 2 seconds of processing is needed here. Okay, so how do we draw this Gantt chart when it comes to first come first search? So let us understand here. So first we will look at the arrival time and we will check which is the process which comes first. Which process comes first? So at 0 interval of time, as you can see, you are writing here at 0 interval, right? At 0 interval of time, this process P2 comes and its burst time is 1. That P2 would execute from 0 to 1 second. Now its completion, the P2 has been fully completed its execution. Only after it executed, the next process would come. At 1 second, no process has come. So at 1 to 2, there is no process in the CPU. And after 2 processes are coming whose arrival time is 2. So then we will look at the writing order. That is, first process would come. So P1 would come and its burst time is 2. That means 2 plus 2, that is 4. So till 4 seconds this is arriving. Now it is 4. So in the 4 second P3, when you are considering till 4 second, how P3 would also come, P4 also would come, P5 would also come, right? because when it reaches the 4 second, P3 can also come in the ready queue. P4 is coming at 3 seconds, so P4 would also come, P5 would come. Now how do we choose from this? Based on the arrival time. Now since P3 has the less arrival time, now we will assign the CPU to P3, whose burst time is 3. That is 4 plus 3, that is going to be 7. Then we will assign this to the next less arrival time, that is P4. So P4 is burst time is 5, that is 7 plus 5, that is 12. Now we will give the CPU to the next, that is P5, whose burst time is given to us as 4, that is 12 plus 4, that is 16 here. So this is how we are going to give. This is a final answer actually. Now if you wanted to, if in the question actually, if in the question it is asked for us to, okay, you have to calculate the completion time. You have to calculate the completion time, the turnaround time, the waiting time, the response time, and first let us calculate the completion time. Now completion time, if I am drawing another box here for the completion time, if I am drawing another box here, you can see that first P1, when is P1 completed? P1 is completed at 4 seconds. So you write here 4 because P1 is completed at the 4 second. Right, after 4 seconds only the P1 is completed. Now P2 is completed after 1 second. So P2's completion time would be what? 1. Now P3 if you check it's 7. So you write here 7. Now P4 if you check it's 12. P4 is 12. Now P5 is 16. This is the completion time. Now if you want to find the turnaround time is the arrival time and completion time. The time between this arrival and completion is the turnaround time. So you can just do completion time minus arrival time. That is, if I wanted to calculate the turnaround time, and if I'm drawing a box for the turnaround time, I can say it is the completion time minus arrival time. Right, this is the completion time minus the arrival time. I would say the turnaround time is, so the completion 4 minus 2, 2, 1 minus 0, 1, 7 minus 2 is what? 5. Right, like that you will calculate the turnaround time. Now if I want to calculate the waiting time, now let us say I want to calculate the waiting time, how much time the process would be waiting in the ready queue. That is the turnaround time minus burst time we have to do in order to calculate. So we have completion time minus arrival time, we will calculate the turnaround time. Now that turnaround time minus the burst time, when you do, you basically get the waiting time. This would give us what? The waiting time. Now response time is what? Response time is nothing but, see, the processes are arriving at this time, but just getting the CPU, if I'm considering P1 is arriving at 2 seconds. P1 is getting the CPU at 2 seconds. So the response time is 2 minus 2, 0. Consider P2. P2 is arriving at 0 second. It is getting the CPU at 0 seconds. So 0 minus 0 is also the response time is 0. Now if I'm considering P3 is arriving at 2. But P3 is getting the CPU only at 4 seconds. So 4 minus 2, 2 is its response time. Now let's consider P4. P4 is arriving at what? The P4 is arriving at 7 seconds, but arriving at 3 seconds, but it gets the CPU at 7 seconds. So 7 minus 3, if I'm doing, it's 4 seconds. Now P5 is arriving at 12. It is getting the CPU only at 4 seconds. So you are doing 12 minus 4. This is the case of finding the response time. So a quick revision of the concept. Completion time you can get from the Gantt chart. Right, you are getting from the Gantt chart. Okay, completion time. Then after that you are calculating the turnaround time, which is basically the completion time minus the arrival time. Then you have the waiting time, that is the turnaround time minus the burst time. Then you have the response time, that is the time the CPU is given to the process, and then you have to minus that with what? The time the CPU is given to the process, you have to minus that with the arrival time. This is the conditions that you have to understand. So in the next video, we will come up with next scheduling algorithm. So then, thank you.